Good morning, students. Myself, Dr. BADI ALEKHYA, Assistant Professor, Department of Artificial Intelligence and Machine Learning, R.M.D. Engineering College. Today, we are going to discuss one of the most interesting and wonderful concept in deep learning, convolutional neural networks. Let us see what is the purpose of using convolutional neural networks in deep learning models. So convolutional neural networks is a powerful type of ANN, artificial neural networks that well suited for processing image data. That means convolutional neural networks we are using mostly in image processing, image segmentation and image classification applications. So, what is the inspiration and motivation of considering convolutional neural network in deep learning model is it is having the hierarchical process. Uh, it's having a layer processing structure for handling complex features and also feature extractions. That means considering the edges, shapes, and textures, how our brain recognizes that objects and spatial invariance. And not only shapes and structures, it is also helpful in the variations of positions and orientations of objects, allow them to recognize the same object regardless of its location. For example, if I see one image at one point of time, the affected image, if it's not the same location, it's in the some other location, the affected part is there means these convolutional neural networks will helpful to easily identify the object, recognizing the object with irrespective of its location. So convolutional layer, it is one of the important terminologies we are used under convolutional neural networks, responsible for extracting the features from the images. Already we discussed that we have some of the important hyperparameters in convolutional neural networks. One of that is filters. How we are going to use the filters in the convolutional neural networks we will discuss in the upcoming slides, and feature maps, how these filters created the feature maps, and operations, how we are performing operations to identify the patterns and spatial relationship between the pixels of convolutional neural networks. See, if we are considering the input image we are going to considering in the form of matrix, and we are applying the kernel filters. If we considering 3 cross 3, so imagine that if we are considering 3 rows, 3 columns, and the kernel size we have to consider 2 cross 2, how we are going to add means A into W plus B into X plus E into Y plus F into Z. Like that, we have to create a convolutional by considering the input image and the kernel size. So in this way, we are calculating the input. How padding and strides will be is performing. We are going to consider, for example, we are going to consider 5 cross 5 one image into a 6 cross 6 one image, and then apply 3 cross 3 one kernel over it. How the convolutional matrix of dimension 5 cross 5 one, hence the name we call it as same padding. On other hand, we perform the same operation without padding. How it is going to represent with a matrix which has dimensions of kernels 3 cross 3 1, that means 3 cross 3 filters with stride 1 itself valid padding. So same padding, valid padding, let us discuss with the example. See, convolution with padding and no strides are there. If you observe the diagram, you come to know how is the convolution is performing padding with no strides. Just look it into it, how it is performing padding with no strides. And move to the next thing, convolution with padding and stride twos. If you observe carefully how it is moving by lifting the two columns at a time. Please look at into that convolution with padding with stride twos. And convoluting a 5 cross 5 image with a 3 cross 3 1 kernel to get a 3 cross 3 1 convolution convolved future vector. If you observe, Please look at it carefully how it is calculating. Initially, I gave some formula how it is calculating the values into it. We are going to convert into 3 cross 3, 1. 3 rows, 3 columns into one straight feature. So the kernel shifts 9 times because of stride length 1, non-strided. Every time a matrix multiplication operation will be performed between the k and the position of the image where the kernel is hovering. So how it is going to perform with red, green, blue RGB channel has the same depth as of input image. Let us see with the example. Observe it. The input channel red 1, green 2, blue 3, how it is converted into kernel how it after applying this matrix to the kernel channel 1, 2, 3 and adding the bias value 1, how it is calculating the corresponding values at the output of the convolution networks. Observe it carefully how it is calculating. Same thing, matrix multiplication with kernel and adding the bias will generating the values at the output matrix. Observe it carefully. When you are calculating, please considering these things and calculated on your own how it is going to perform the operation on it. So now come to the we are observing kernels, filters, and we are calculating the convolutional feature vectors, and then we are going to move to the stride values. We are considering discussed padding. We discussed stride values. We discussed next important concepts under convolutional neural network is pooling layer. Here, this pooling layer will be used to reduce the dimensionality of feature maps. If you observe that here we are considering some big matrix is generated 1, 2, 3, 4, 5, 5 cross 5 cross 1 matrix will be generated with stride fact 1. Now we are going to reduce this dimensionality of this matrix that feature maps. We are going to apply pooling layer techniques. Either we can use downsampling or invariant to translations, and also we consider types of pooling. Let us discuss with example. If you are considering the max pooling techniques, among this, if you observe that in this matrix, if you are considering 2 cross 2, among 4, 9, 5, 6, which one is the maximum value? 9. And 2, 2, 2, 5, 2, 4, which one is the maximum? 5. Like that, we have to calculate max pooling. Like average also, we are going to calculate the average value and we can store it in particular matrix. So activation functions we are mostly used to introduce the nonlinearity into the networks to learn the complex relationship between the features. Mostly we are using here ReLU, sigmoid and tanh. If we are dealing with binary classification, we are using sigmoid, and hyperbolic tangent values we are using minus tanh. And effective activation functions we are using a rectified linear unit, and also if we are using multi-class, if you are considering multi-class classification, we are using softmax. And fully connected layers, each class with all the neurons in the previous connected to the in the previous layers to all the neurons in the current layers. Fully connected means nothing but previous layer neurons is connected to the current layer neurons in the simple way of understanding. What are the two functions at the output? What the fully connected layers, what are the two functions we are using is classification and regression. In the classification, if we are going to match the features in the probability distribution over classes means we are using classification techniques, or otherwise if you want to predict a continuous values so of an object size or location, we are using regression techniques. So these are the some of the popular architectures we are used under CNN. Uh, so earlier we have an application of CNN, handwritten digit recognition. This already we did in our lab. Linet 5, AlexNet also we are using under ImageNet computations, and BGG In data augmented VGG model, we are using for simplicity and effectiveness of multiple convolutional layers. For HCDL connections, stability and accuracy, we are using ResNet. These are some of the popular architectures to be customized by the CNN for specific task. So training convolutional networks, we have back propagation, optimization, data augmentation, and validation. These all things we are studied in the starting of our videos. What is back propagation? What are the need of optimization? What is data augmentation and validation? Please refer my previous videos to understand these concepts in detail. And in real-time applications of convolutional neural networks, we have object detection, handwriting recognitions, and medical imaging. These are the some of the applications when and where we are using convolutional neural networks. So that's all, students, for the today's sessions. We will meet with some other new concept in the next session. Thank you all.